do this. Okay, so we're going to underline the polynomial functions and circle the rational functions. So go ahead and just go through those 12. Circle polynomial. No, underline polynomial, circle rational functions. And don't do anything if they're not polynomial or not rational.
Circle the rational?
Circle rational, yeah. I do want to say just because I have a fraction does not mean that it's necessarily rational. So it depends on the type of fraction it is. So there should be 4 polynomial functions and 6 rational functions in your circling and underlining. Okay, so what about the first one? What is it? X to the 4th minus 3x plus 1. Polynomial, that is correct. Second one, the square root of 2x plus 1. Neither, good. X to the 1st, x to the negative 1st plus 3. Neither, yep, good. Polynomial has to have positive exponents, yeah? 3 over x to the negative 2.
No.
Rational, good. X plus 1 over x squared plus 3x plus 2. Rational. 3 plus 2x. Polynomial, good. 2x minus 1 over x. Rational. X squared minus 4 over x plus 3. X squared minus x minus 12 over x squared minus 9. X to the 5th minus 3x to the 4th minus x cubed plus x squared. Polynomial. 1/2 x plus 5. Polynomial. Good. And 2 over x plus 10. Rational. Because my x is in the denominator, so it's rational. Okay, good. Good. Good job, you guys. Hope you guys got those right. Next page, we're going to talk about domain. Domain, just as I just put the definition, you guys all know the definition, but I just put it again. It's all the values that go into a function. that go into a function. So that's my x values. So my domain are my x values. Another way, x values that go into, that's my x values. How to find the domain of a given rational function. Set the denominator equal to 0. So there should be one more step before this. This is, sometimes, I'm going to say sometimes, I can't, not all the time, but sometimes I have to simplify the fraction, simplify it first if it's a rational function. So sometimes we have to simplify it. Okay, so in Delta Math, you may need to simplify it first. Just need to tell you that. So just need to say that. So I'm going to set my denominator equal to 0. Solve to find the x values that cause the denominator to equal 0. The domain is all real numbers except those found in step 2. Okay, because it's all real numbers except what's going to make my denominator 0. We all know the denominator can't be 0, so it's every number except what's going to make the denominator 0. That's what my domain is for a rational function. Oh, that's not you guys. Okay, so is number 1 a rational function? It's a polynomial function, right? So what's my domain of a polynomial function? Ooh. Who remembers? No, domain. So what x values can I put into a polynomial function? Are there any x values I can't put in there? No. So what would my domain be? Infinite. Yeah, good. So my domain would be infinity to positive infinity. Or you can say all real numbers like that. It's a double R. Double capital R means all real numbers. So next year, if you guys are taking calculus, you may see it this way. You don't usually see it that way very often, but you may see it in calculus. So the next function, number 2, what type of function is this? 3 to the x power. It's not a log. It's related to a log. A log would have the word log in there. Exponent, good. It's exponential. I have to say, infinity is a real number. We just don't know where infinity is at. Because it's so big, we don't know what it is. But it's still real. Infinity's still real. We just haven't counted that high yet. Right? So somebody just put infinity is not a real number because I put here it's all real numbers. But infinity is a real number. We just don't know where infinity ends at.
Well, it doesn't end.
It doesn't end. But it's still a real number. Our numbers never end. It doesn't make it not real.
It's not a number, it's just meaning all numbers.
Yeah, all numbers. They still have never found an end, and they never will. Because you can just keep adding numbers onto the end and make a bigger number, bigger number, bigger number. So it is a concept. Good. Okay, so by the way, you said this is right. This is an exponential function. So the graph of an exponential function kind of looks like this, right? Looks like that. So depending on where this is at, I have an end here. This could be my axes here. So I need to know where this is because my domain would be wherever this is at on. So I need to know where this part is. The question is, how do I find where that part is? What x's can I put in? What happens if I put in a negative exponent in there? What happens to this? If I put in a negative exponent, what happens? Can I put in a negative exponent?
Yeah.
So what happens?
It means it goes to the bottom. Like it's
A negative exponent means that goes to the bottom, right? So I can put, so am I going to get negatives over here? If I get a negative x's?
no, you just get smaller.
So x is going to be negative. What's going to happen? Let me draw this better. Sorry. For some reason, it's little. So if I have a -1, if x is -1, where's y going to be at? I probably drew
1/3, right?
1/3. Good. So somewhere in here, right? We'll just draw it there. And if I was at -3, where would it be at? 1/9, right? Here. And so it's actually going to look like this. What's going to happen? Sorry. Is it ever going to get to 0? I drew it the first time as a negative. So it's going to look like this, correct? So what's my domain going to be?
Negative, infinity, positive.
Yeah, there we go. Negative infinity to positive infinity. So I just did a really quick sketch. It didn't, it's not an exact drawing of it, but all we had to do is a quick sketch of it, and then we could find it out. Or you could pop it into Desmos really quick. That's a good way to find domain, right? I just know, I'm just going to tell you guys why I do quick sketches, because that's how I learned. I didn't have graphing calculators. They were when I was learning how to do this, so we just did quick sketches of them. So you guys have graphing calculators. You can pop it into your graphing calculator and then do your domain from then, right? So from there, that's probably the easiest. So now if I have I have a rational function. What does it say I have to do? Set my domain equal to 0. So, okay. So x minus 1 equals 0, or cannot equal 0, right? Because I don't want it to equal 0. If it equals 0, it's undefined. So I don't want it to equal 0. So at 1, so x cannot equal 0. So now I have to write my domain a little differently. So my domain is going to go from negative infinity to, oh, why did I put 0 there? Wow. I said 1 and I wrote 0. Negative infinity, it's going to go from negative infinity to 1, and then from 1 to infinity. Go ahead, Conrad. You looked crazy. You looked at me like you were confused, not crazy. Sorry.
I don't know, just try and underline it.
Huh?
Not this one.
So if I was to, something's going to happen with this graph, and I'll kind of show you what this graph is. This is not exact. Don't quote me on this, but this is going to kind of look like fruit and something like this, and it'll have a break in here like this at 1. Okay, so it has an asymptote at 1. We haven't started talking about that yet, but at 1 there can be nothing at my graph. It doesn't exist at 1. So it's going to be split. I'm going to have 2 different pieces to my graph, so it'll look like this. So my domain has to go from negative infinity to 1, and then from 1 to infinity. So the only piece that it's not included is at 1. And when the highest domain. Yes. Is there ever a time when the highest domain number is not infinity? Yes, there is, but it's with different functions. So there are times when it's not infinity or negative infinity. Mostly when you're talking about logs and roots, you don't get infinity or negative infinity as one end or the other end, but it's always, but with most polynomials, it's all negative infinity to infinity. Most rational functions, you'll have it at both ends with some sort of break in between of them. Unless I have, no. Unless I have some restriction on my domain. And none of the problems will have any restriction on your domain. So this one we're doing the same thing. I have got x plus 3 cannot equal 0, and x minus 2 cannot equal 0. So I know that x cannot equal negative 3 or positive 2. Now it gets a little more trickier to write my domain because it's going to get bigger. So my domain is going to be negative infinity to negative 3. Okay? And then it's going to go between negative 3 and 2. And then it's going to go from 2 to infinity. So this time the graph will have an asymptote at negative 3 and one at 2, and it'll have something crazy going in here, and then something crazy going in here, and then something crazy going over here. Find the graphs. Okay? So it's negative, so it's probably flipped the other way, but it'll look all something like that. It'll have 3 different pieces to it. Okay, so now you guys are going to find the, we're just looking for the domain, and that's it. Okay, so try it. Go. So F is, I'm just going to give you the answers. If you need me to explain it, let me know. So my domain is negative infinity to negative 4 and negative 4 to infinity. Here we've got negative infinity to 4, 4 to 5, and 5 to infinity. Nice, Jesse. C, is there any value for x that will make my denominator 0? No, so what's my domain? Everything. Negative infinity to infinity. Yes, Daniel, good. And D, of course, is a polynomial, so that means my domain is negative infinity to infinity. Good. Daniel, did you see the answers on A and B? Okay, cool. Okay, good. So yeah, C was just is a little funky, right? So what I did is I looked at it first. I didn't think about what's going to make it 0. I just put it in and graphed it. And I got this really funky graph. I know you guys can't see it, but I can hold it up to the camera here. Can you guys see that funky graph there? I was like, oh, okay. And then I looked at the problem again. I was like, of course, it's x squared plus 1. So there's nothing that's ever going to make the denominator 0. That's why it's negative infinity to infinity. So I just graphed it first. Is that fine? Well, I told you. I sat here and said you guys could use your graphing calculator. Didn't I? I did. I know I did. So that's not cheating if you use your graphing calculator. So sorry. I used Desmos, which you are able to use on the ACT and the Aspire. Thank you. Okay, next. So asymptotes, although you guys already know this also, you should, is a line that a curve approaches as it heads towards infinity. And it can be straight, it can be a diagonal line, it can be a straight line. It can also be a parabola or a cubic function. It can be a curved function. It's just some line that your graph approaches as it heads towards infinity. Usually it's some straight line, okay? So vertical asymptotes of a rational function may be found by examining the factors of a denominator that are not common to the factors in the numerator. Vertical asymptotes occur at the zeros of such factors. So really quick, they found by examining the factors of the denominator that are not common to the factors in the numerator. So that means, I probably said that a little earlier and maybe not understanding, but it means I need to take my function and sometimes simplify my function before I find the vertical asymptotes, okay? We are going to talk about those functions that are common in both the numerator and the denominator later. There's something else in my graph, but vertical asymptotes are the ones that are not common to the factors in the numerator. Vertical asymptotes occur at the zeros of such factors. So If we look at these lovely graphs and the equations that go with them, so this function is x plus 2 divided by 2x plus 6. This is what this function looks like graphically. And it wants us to find the domain and identify the vertical asymptotes of this domain. So my domain, I have a graph. I can find my domain. My domain goes from negative infinity to negative 3. Right there. And then from negative 3 to infinity. Okay, and my vertical asymptote is a line. It's a line. And it's the line x equals negative 3. That's it. Okay, questions? Not too bad? Pretty easy, right? Okay, so if we look at the next one, same thing, right? This is the function x squared plus 2x divided by negative 4x plus 8. And I think that I think we can simplify this function, right? So if I take an x out of the top, I get x plus 2. And I think I can factor, oh, nope, it's not, because I factor out a negative 4 and I get x minus 2. So I don't have anything in common here. I was hoping I would so we can factor, so we could cross something else, but it isn't. So I can find my domain again. My domain goes from negative infinity to, oops, wow, okay. Negative infinity to 2, and then 2 to infinity. And my vertical asymptote is x equals 2. Questions? You guys okay? Not too bad. Not too bad so far? No adding, subtracting, or anything right now. We're not solving anything. Okay. Okay, so you have 3 problems to find the vertical, oh, let me make it bigger. To find the domain and the vertical asymptote for, so go. Okay, here we go. A, domain is negative infinity to negative 3, and negative 3 to infinity with a vertical asymptote of x equals negative 3. B, I'm going to write underneath it, I guess. My domain is going to be negative infinity to negative 1 to 3, and 3 to infinity. And then I have vertical asymptotes at x equals negative 1 and x equals 3. And then for C, same thing. I'm going to have a domain at negative infinity to 0, 0 to 3, 3 to infinity, and vertical asymptotes at x equals 0 and x equals 3. Questions? Wow, okay. And then the last thing we're going to find is actually find the vertical asymptotes algebraically. All you have to do, simplify first, and then set your denominator equal to 0 and solve for x. I believe all the ones that we've given you have already been simplified, but I do want to say you need to simplify because I don't think all the ones in Delta Math have been simplified. That's why I'm saying simplify first. Okay, so very simply, right, I'm going to say x minus 1 equals 0, add 1, x equals 1. There's my vertical asymptote at x equals 1. That's it. Period. So 2x plus 8 equals 0. Subtract 8. Divide by 2. X equals negative 4. So once I solve for x, basically, if I have my x in there, it's already in equation form. So it's just x equals negative 4. For 3, x plus 3 equals 0, and x minus 2 equals 0. So I get x equals negative 3, and x equals positive 2. Is there any questions? Pretty easy? You guys not too bad? Are you guys okay with that? Okay. Oh, good, I am recording. Whew, here's a 6 problem. Okay, let's really quick. Let's see. A is x equals 4 and x equals 5. B is x equals negative 3, x equals positive 1, and x equals negative 4. C is x equals 0. D is none. There are none. E is x equals 4. And F is x equals 2 and x equals negative 2. And everyone who put answers into the chat box got those correct. Good job. Oh, sorry, the last thing is just a little self-rate yourself in the chat box. Right? If you can find the domain and vertical asymptotes of a rational function. Thank you.